question?
Yes, by the way, we're live now. Electrons in the periodic table.
When elements arranged.
We're going to find out today that the periodic table has this shape for a reason. The shape of the periodic table is directly, and I mean directly related. There's no reason for talking. To the structure of the atom. This reason it has this funny shape is because it is telling you how the electrons actually fit into the atoms. Now, at first glance, we're like, oh, how is that possible? But you'll see that the valence electrons, the ones at the highest energy level, are the ones we're going to focus on, and you'll see how that note, this big star note, jumps off the page by the end of this lecture. Why are the valence, the ones on the outside, do you think are the most important? Just give me a guess. Yes.
For chemical reactions, they move.
For chemical reactions, they move around. What makes sense? For instance, what is probably the biggest barrier between you and the environment?
Air.
No, you and the environment, like your body and the environment. Air is the biggest barrier? No. What, say that again?
Skin.
Skin, that's correct. In other words, your outer part, your skin, is this organ that you have called skin, is it's your biggest defense against the environment. It's the one that interacts with it the most. Same with the valence electron, it's like the skin of the atom. These are important because they're the ones that interact with the environment. They're going to be, as Jack said, the ones that interact for chemical bonding. And as Samuel said, they are the skin of the atom. So again, that point's going to jump off the page once we start seeing how the electrons are filled here. And again, same note, written a little differently. Same idea. The chemistry of the element is largely due to the action of these electrons. Excellent. I love how I said you would need 6 balloons, and yet all of you brought in models with 7 balloons. Makes me
I brought in 2.
Well done. That also is incorrect. You will need 6 balloons. I brought in 2.
I brought in 1.
I brought in 7. And I brought 1.
I brought in 6.
Just in case one
pop. Just in case one pop.
And a random one?
Yeah.
All right, you're the man.
I didn't bring any.
All right, let's see if you guys can start getting this idea. All right. Let's look at this real quick. Let's look at this.
Looking at
An S sublevel can fit how many electrons? It has 1 orbital. It can fit 2 electrons. Excellent. Here's what I want you to notice about this group right here that sticks up like a little building. If I count how many elements wide it is, how many elements wide is it? It is 2 elements wide. Now, helium is over here. We're going to find out that helium is over there, but it's number 2. It should kind of be right here structurally.
yeah.
But we put it here for a reason, and you'll see why in a second. But yes, this is 2 groups wide. Got it. Oh, that's interesting. All right, a P sublevel has how many orbitals and can fit how many electrons?
6.
It can fit 6. How many orbitals?
12. 10.
12.
4, 6, 10, 7.
2. Each orbital can hold 2 electrons.
12.
It can hold a total of 6 electrons. So how many orbitals does it have? So no one studied our notes last night. It was 3. The answer to that is 3. 3 times 2 is 6. Now wait, let's look at this little area here, this block, this building that sticks up. Now if I count how many elements wide, it's 1, 2, 3, 4, 5, 6. I start to rub my chin. in wondering and
That's
pondering.
weird.
A D sublevel is made up of how many orbitals?
Oh wait, no, wait.
5. How many electrons can it hold? 10. Now I go in between these two buildings, this tall building and this fat building, and guess how many elements wide this middle area is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is going on here? And then lastly, there is an F sublevel. It can have how many orbitals and fit how many electrons?
18. 7.
7 orbitals.
14. You can count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What? Huh? Is something wrong?
When we start filling them in.
Notice we're missing 2 spaces here on purpose because 2 of these go up here. This block is also 14 elements wide, and it actually belongs in the table. But rather than the table be 14 more elements wide, they've now put this block to the bottom to condense how the table looks. So what I'm telling you is that this is actually structured because this is how electrons fill the atoms. And so if you follow along, which I know you will, you're going to be able to give me a good model of the atom, actually a pretty good picture of the atom after today. All right, and the reason that elements and groups have similar properties is because they actually have similar configurations of their electrons. We just saw that these groups are, because of the S and the P and the D and the M. So that means elements and groups are going to be very similar. Oh, this is triple starred on both sides of the note. Wonder if that's going to be a question on a test or a quiz.
Probably not.
I don't think we need
Yeah.
This is a new song.
No, this
We
is,
do
they've
have the
done
little
this one a
variety,
couple
which
of
is
times.
so nice.
I think we're up to 3 songs now.
I hate children.
It's like,
I love.
either way, that's not sounding good.
Yeah.
You can't say that.
No matter how you
And
say
now
it.
all of YouTube heard him say it.
Well, it's just how you, in that creepy sense, you're allowed to like people, that's not hard. But you can't just say, I hate children, or I like them.
This is the end of the video.
You like children?
We're gonna edit this out.
4K.
Yeah, we gotta edit
No,
this.
no,
No,
live
no,
stream.
We're gonna clip that.
4K.
We're about to get canceled.
Not 4K.
All right, zone it back in. So now all we need to do is figure out how to do these electron configurations. So can we do that? The answer is yes. Example.
Whoa.
I'm not giving you an example now.
Oh.
Dang it.
Well, this one I kind of already gave you. Orbital blocks.
Wait, whoa.
Wait.
So-
It's different here.
And of course it is, because they kind of, so here's your, they kind of separated it for you, and then they stuck the F block in there. That's because we have to shut the doors and our vents don't work. But that's been the way for a long time. By the way, just so you know, you're on video. Okay.
And this is going by.
This is a lecture that goes online.
Because we're speaking.
All right, I have a, don't we?
Don't say that, you're very smart,
smart,
you
but
just
we
need
need
to
to
hear
hear
it
it
twice, black people do.
Turn
Cut
down.
down.
No, our vents need to work. It's fine in the room.
They, yeah.
No, don't work. Work in the other room. Okay. Not really, but that's okay. I don't have time. We have a drill.
Do we have a drill?
We have a drill today.
What?
Is it lockdown?
They're all
drill?
wrong.
Yeah.
What drill?
Thank you.
They are.
You guys are gonna join us?
Yeah.
or-
Good job trying.
It was. They got
I
it.
think we got 1 point. Thank you.
Bro, we're gonna have a live fire drill.
Only Mr. Lesniak gives you points for things that are wrong.
Okay, so what's the drill?
Wait, is it not a
Zero
lockdown
does.
drill that we're gonna die again? Like
All right.
last
Hey,
year?
let me get a helmet.
Refocus. Groups 1 and 2 are the S block. Now look, I'm not, yeah, you can cut this one out. You guys are going to draw these at home, by the way. I'm gonna add it to your assignment. No. You're just gonna be able to color these. It's not hard.
Oh.
Well, it's gonna be one at your time.
Oh.
It's gonna just wanna make it look like this.
Did you get it?
I already did that.
I don't mind you guys cutting out your things and putting them in here because that's where it belongs. But it should take talking to do that. Yes, if you think you do not have this figure, turn your papers over. Remember, there was one that was mistakenly two-sidedly printed. All right, so now we're in the S block. If you glue these in, you know what the next notes are. What's going to be the next note?
The D block?
Yeah, we're going to get, well, we won't go to D, but
P.
Probably not D.
G,
I vote G.
S block. Hydrogen and helium are in there. These are the elements where the valence electrons are found on the S level, sublevel. P block. Groups 13 to 18, these have a filled S orbital. Sometimes the D, F, and P orbitals are being filled during this time. You'll get to that here in a second, but it's groups 13 through 18. Again, getting these notes down is important. Actually doing the things is what's really important. But you can see that these can easily be questions on a test or a quiz. Let me give you an example. How many orbitals are in a P sublevel? And then you have choices.
7.
The answer to that is 3.
Who said 80?
I can't wait. This video might go viral.
Are you gonna edit anything out?
I'm not.
Mom, I made it.
Well, you had to film the fire drill too.
All right.
It's a lockdown.
It's
S,
a lockdown.
P. What do you
Wait, I
think's
can do a
next?
POV fire drill.
What do you think's next?
That would be really funny. It would actually be hilarious. It would be fun.
3 through 12, these are called the transition metals. The d orbital is being filled. Starts at 3D. We'll get here in a second at what I mean. This, if you do highlight or underline something, I would highlight this whole starts at 3D because that's important. As you write it, circle it, highlight it, star it, do something. Maybe I should do that.
I don't understand why they just picked random letters.
Yeah, it feels like that.
I don't know why they mentioned the SPDF. I'm sure there is a reason.
Probably some weird Latin term or something.
My guess is has to do with the wave function or geometric planes. But that's a total guess. I've never had anyone ask me that question.
It's just PDFs.
You? You haven't even got the mistake.
I just think random letters are difficult to remember unless we know why they chose them.
I agree. But now it's not random. Now they have to do with the periodic table and electron configurations. And who can guess just the next note? Remember, highlight that starts at 3D. Who can guess the next note?
F block.
There it is, the F block. These are the inner transition metals. Starts at 4F. That's the one you want to kind of circle slash highlight slash. Starts at 4F. Those are the big points. Starts at 3D, starts at 4F, and of course that's when the F block's being filled. Cool. So let's do this. Okay. Now, here's the reason we've gone through this. Because if I said for each one of you, let's draw the atom, we already know, guess what? We can't do that. This is why we use simple Bohr models to help picture what the atom might be, especially at lower levels of chemistry. But now we're in high school chemistry and we're going to need to know, okay, structurally, what does this atom really look like? And so if I were to ask you to try to depict the atom, first of all, a nucleus is so small, do you even need to draw anything? No, it's just tiny, it's irrelevant. Plus, does the nucleus have to do with anything when it comes to general chemistry? The answer is no. Nucleus only has to do with things like half-lives and radioactivity, which we only talk about very, very shortly. And we don't, that's not have to do with everyday chemistry. So, if I asked you, hey, give me your best picture of an atom, here's what you're actually going to do. You're going to do what are called electron configurations. And this is the distribution of the electrons among the sublevels of the organ, of the atom, sorry.
Just give me a picture.
It's kind of a picture. And here's the reason it works for you guys, because you guys actually have pictures of what an S sublevel looks like, what a P sublevel looks like. We know what a P sublevel does not look like.
Okay.
Understand, tried and wrong.
My name is right.
No.
It looks like the.
Oh. Whereas.
It's funny you got your name on video.
Nice.
This video is
Who
gonna be
made that?
great.
I'm like, getting my popcorn and watching the
Alright,
video.
so we know what they look like,
Okay,
but that's not a really good depiction. Alright? So here, let me just ask you, if I wanted you to maybe, just maybe, describe to me what a hydrogen atom would look like without using shape, just using like your brain, the periodic table, here's what I would see. Hydrogen is number one, which means in a neutral atom it has one proton, right, Moseley, and one electron. Do you see how those balance out? So in other words, for neutral atoms, the number of protons and number of electrons are
1 and 1. Same.
the same. So if I go anywhere, if I go down to potassium, it has 19 protons, and a neutral atom would have 19 electrons. So if I want to just give the picture of the number of electrons in an atom and what that picture looks like, all I got to do is look at the atomic number. Now, we're going to find out that that's not going to always work for bonding because they like to give their electrons away or share electrons and do things like that with electrons. But when it comes to writing what they look like, hydrogen only has one electron. And how do I describe hydrogen's one electron? Well, that's where the beauty of this. So this periodic table should help you out very much. What I want you to do now is let's number these things going across. These things going across are called periods. We'll define that a little bit later in our lecture. But I just want you to number them starting one at the top. 1, 2, 3, 4, 5, 6, 7. That's it. Right off the side of that.
Both sides are
Just that one, it's fine. What that actually does, believe it or not, this number on the side here, the period number, is what it's called, is actually going to tell you the energy level of the electrons. So, for hydrogen's one electron, it's on energy level what? 1. What? Energy level 1. Which block of the periodic table is this right here? It's not the 1 block. We don't have a 1 block.
It's the 8 block.
Say that louder.
S.
This is the S block of the periodic table. Okay? That's the note you just glued in. Okay? That's the S block of the periodic table. You can't have a question yet. Not allowed. S block of the periodic table. And how far over in the S block is that electron? Well, how much over do you have to go from here to get to there?
Just one.
Just one. It only has one electron. Energy level 1, sublevel S. one electron in that sublevel. Guess what you have just done?
Something terrible.
You just did your first electron configuration for the atom hydrogen. That's a whole
It goes downhill from there.
No, it doesn't. It's actually this easy. Let's do helium. How many electrons are in helium? 2. What energy level do you find helium at?
1.
It's at energy level 1. It is in the S block.
Oh, I see it.
But how far over on the S block is it? Because remember, it should be right here. It's 18 over. It should be right here.
1.
It's 2. Remember, an S can only have 2 electrons. So don't worry, it'll make some sense here in a second. But that one didn't make sense. You've actually done your second electron configuration. Helium's 2 electrons are found on the first energy level in an S sublevel. That's where helium's electrons are. All right, let's go. We can actually do lithium. Lithium has how many electrons? 3. Say that louder because a lot of people said different numbers.
3.
Thank you. 3. Why? Because it's number 3.
Oh.
Now, in order to build up, because we got to count for all 3 of the electrons, in order to build up to lithium, I'm going to have to go through the first energy level, aren't I?
Sure.
First energy level, like a typewriter, ding! I go down to the second, and now I can find lithium. All right? So in other words, for lithium, I have to go through the 1s and fill it completely. So I have to put that down. It's filled with its 2 electrons, but I do have to go to a 2s. And how far over do I need to go?
1.
Very good. 2s, 1 over. And if I start adding these numbers up, I should have the right number of electrons. I should. Well, that wasn't hard. 2 plus 1 is
3.
So lithium's 3 electrons will organize 2 of them on the inner energy level. Then we'll have an outer energy level of 2 with 1 electron on it. Oh, we're gonna throw a slight curveball on you. We're gonna go down to, because in the same group, they're supposed to have similar electron configurations, right? You just took that note. So I'm gonna go down to sodium. Sodium has 11 electrons. I'm just holding my periodic table here, so I need to go to sodium, Na. And how do I build up to sodium to hopefully represent 11 electrons? Well, I gotta go through the first energy level, right?
Yeah.
1s1, 1s2, fill it up. Then I go where? As I go across the second one. 2, 2s, 2s2. Now this is the first time we've ever done this. As I go across the periodic table, I'm going to enter into what block? P block. And of course, to get to 11, I have to fill that completely. So how many across is that?
6.
It is 6. And it's on the second energy level. How do you say? Almost. 2p6. Very good. You guys are rolling. Now we're getting very close. We should be getting to sodium. We're now on the third energy level, and how far over are we?
1.
So what should I write?
3s1.
If I count my electrons up, 2, 4, 10, 11. This is how sodium organizes its 11 electrons. All right, so far so good. Now, what do you need, Sophia? Oh gosh, I don't know. Time, exact time.
9:07. 6 minutes past 9.
9:06.
9.
When's the lockdown?
Why do people
Quick.
say that? Why do people say this?
9
That's past.
All right, refocus.
It's like this more confusing. I want to get a drink of water, but
Refocus, because I'm just gonna. Yes, we got a question.
How would you do O'Ginnison?
Okay, so now, how about we just? Okay, that's a good idea. How about we just go to something that's super duper tough?
Yeah.
All right, I'm gonna go down here. I'm gonna do osmium. It's number 76. I'm gonna do it. You don't need to do it. All right.
Wait, no, I can't get
But all I'm going to use is my periodic table of elements. I'm not going to use anything else. I'm going to sit it right here, and I'm going to just go through the blocks. But I know the notes already. You don't know the notes yet. You're going to have to study the notes. In fact, you're going to end up coloring this periodic table to help you do these electron configurations this week. But I'm going to do it, and you're going to see, I'm going to do my thinking out loud. I don't have to count my electrons. I don't have to do anything. I know I'm going to end up right here, osmium. It's right here. I know exactly how this should end up. All right? Good. Here we go. 1s2 is filled. 2s2 and 2p6 are filled.
Wait, this
I go to the third energy level. 3s2 and 3p6 are filled. Now I'm going to the fourth energy level and some things start to happen here because it's the first time I'm going to enter my D block. But watch this though. I know that this is 4s2. I know it's going to be filled because I got to get to 67. But now I enter the D block for the first time.
Yeah.
You should be listening. You don't need to write. This is going to be on video. Listen. Watch. I entered the D block for the first time. Remember though, the D block starts at 3D. It does not organize on the same energy level. So I have to know that this is 3D. Your note says it. This is what happens. And people are like, why does it do that? This is what happens in nature. Don't ask me.
Wait,
Ask God.
that doesn't make any sense.
It doesn't matter. Ask God.
Say it starts at 3D, so you go above.
3D10, I've got to fill the whole thing. Because again, I'm getting way down here. Just watch. Now I'm back into the level 4. I'm at 4P. I fill it up. Now I'm going to 5S. This is no longer 3, it's not 5, it's 1 lower, so if that's 3D, that's got to be what now? 4. It is 4D. I have to fill that up all the way. 5S. Then I go, oh, I'm in the right period finally. Woohoo! I'm now at 6.
6S2.
It is 6S2, but now what happens? Oh no!
We go through the F14.
I got to do my F14. I can jump out of the periodic table, finish my F14. All right, but what does the F block start at according to your notes?
What is the wood?
57. Wait. 10.
4F.
Gotta be 6.
Yeah.
It starts at 4F14.
Wait, can I scroll?
Then I have to jump back into the table. This is 3D, 4D, that's 5D. Now I'm in the right spot. I can go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That will stop me at osmium. That's now the 5D6.
Easy.
Now, again, if I'm right, I should add up all these subscripts that are the electrons, and I should have 76.
Why is it 5 if it's on the 6th level?
It is, because remember, this all organizes one energy level over. That's 3D, that's 4D, that's 5D, that's 6D.
Oh, in like the diagonal.
So, let's see if I'm right. 2 and 4 is, 2 plus 2 is 4, 6 is 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 56, and 14?
70.
And 70 plus 6 is?
76.
This is how osmium organizes its 76 electrons. You don't have to memorize any chart. You don't have to do anything. It's because this chart is based on the structure of the electrons.
You're just counting.
That's why they're there. All right, so you guys now. You guys walk. Oh, I better put my walkie-talkie on.
Yeah, you have 4 minutes.
What's the drill?
I'm about to get shot.
So this is I think
Tornado drill.
we're in a drill like intruder alert.
We died in the last one.
Yeah, freaking Berkeley.
Yeah, Berkeley cooked.
Just go outside and we'll go to
Alright,
your car.
you
and
guys.
your gun and we're good.
I want you guys to give me nickel number 28. You guys are gonna walk me through it.
Alright, sorry.
You guys give me nickel number 28, and you tell me what to write. I'm gonna just write what you say.
Okie dokie.
1S2, right?
Yeah, 1S2.
1S2.
Yeah, sure.
Then 2S,
Two.
2s2. Yep, I like that. And then
Somebody else, Junior.
Yeah, be quiet.
Two.
Just kidding, I can't do this.
3s2.
No.
1s2, 2s2.
Wait.
2p6.
Keep following along.
2p6.
Who said 2p6? That was good.
you can,
All right, give me somebody else.
I can't see
you can
anything.
just do the same thing until that row.
True, but just using it, go and build up.
3s2.
3p6.
I kind of understand it.
Where are these numbers coming from?
Because 1s2.
3D what? It's not 3D something.
It equals 2.
Bang. Easy.
1, 2, 3, 4, 5, 6, 7, 8. We stop at nickel. This is nickel's electron configuration.
We did it.
At least we'll find out. Some of these end up being a little askew, but we'll find out those later. That's correct.
Thank you.
Can we do another one? Sure.
I need more examples.
Yeah, I don't like these.
We should do
I need
holmium.
to
Holmium. Holmium.
Let's do like an easy.
Can we do Lars?
You pick one.
Uranium.
Holmium.
Where's uranium?
It's in the F. It's in the F.
Holmium.
Uranium.
Uranium. Holmium.
It's in the F.
All right, titanium. I like titanium. Titanium
Put
number
holmium in.
I found it! Okay,
22.
Uranium.
Wait,
Titanium.
22. Uranium.
Exact same thing as last
Titanium.
time, but change the last one to 4 instead of 8.
All right, hold up.
Oh.
Then it goes, it's the exact same as nickel, except we're going to change the 3D8 to 3D what?
2.
Yeah,
Really
3D2.
great, the red.
What's that?
4.
You would be correct. So titanium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and titanium is 2 over 3d2.
Where did he?
Oh.
Yeah, that makes
Why is
sense.
it-
Let's do uranium.
The letters are the round.
Titanium is number 22. Again, now if I add these up, it'll be
Makes sense.
22, but it's only 2 over in the D block.
So would it be smart, like on a wizard test, to write each of these down and then they can just take them?
It would be very smart to just know where those blocks are, and that D starts at 3D and F starts at 4F.
Wait.
If you know those notes, yeah, you're gonna start being able to do these, rolling them out. But the biggest thing is what you're gonna be doing on Thursday and Friday is practicing them, writing them out over and over again. Okay, we're now in code red.
Everyone tell them the truth.
Wasn't last year like code?